Are we right?
Yep, gonna get started.
Cool.
Okay, hi everyone. Welcome to the MDC 318. And today we're going to be talking about Kiwibank's experience in using SCOM 2012. I am David Graham from Kiwibank, enterprise architect with Kiwibank, and I've been with the bank for 8.5 years and have been using SCOM off and on for about 4 years with Kiwibank. And we've been focusing a lot in the last year on giving ourselves an end-to-end channel monitoring experience. So before we were monitoring servers and infrastructure components, but now we're moving up into the application layer and actually monitoring our IT services as a whole.
My name is Brian Wilson. I'm an infrastructure consultant with Intergen in Wellington, and I'm part of a team who specialise purely in the System Centre suite, primarily I should say. And we've been engaged with Kiwibank to provide consulting services around System Centre, primarily in SCOM, and also talking about some of the other System Centre products. So today our session here is a level 300 session, so we're assuming you guys know a bit about SCOM. You've hopefully got SCOM in your environment, you're using it day to day. We're not going to be focusing on the SCOM infrastructure side of this, purely targeting at particular pieces of application monitoring and helping you guys get your maximum benefit out of using SCOM. Can we just ask you to leave questions to the end, because there's a significant amount of information to cover, and we've also got some other chaps from our respective organisations here who can also ask some questions around that infrastructure space.
Cool. So I guess what we were asked to do by our steering group on our project was to give not just a patchwork view of the monitoring where we got out-of-the-box management packs, but to give ourselves a full IT service monitoring. So from the customer experience all the way back to our core banking systems and then back out again. With the out-of-the-box management packs, we were able to get point monitoring on our SQL infrastructure, BizTalk, Windows servers, etc. But within Kiwibank, we also take a lot of pride in owning the customer experience. And so we write a lot of the front-end applications, so our own internet banking application, our customer and account management system that the call centers use, and also out in the post shops. That's all written in-house, and so there's obviously no management packs available for doing that. So what we had to do was create our own management packs, and this talk's really going to focus on the experience we had doing that, the tools and techniques, and we'll show a bit of a demo about what's involved in doing that. So one of the major decisions why we went down the path of creating custom management packs is it allows these objects that you have in SCOM to represent actual Kiwibank services and systems, and this is allowing the various areas of the business, from your operational teams, developers and business owners, etc., to actually understand the quality of service of the key systems using standardised, understood terminology throughout the environment. Yeah, and I guess the key takeaway for this was there was quite a bit of learning for us, specifically in what key skills and techniques were needed to build these management packs. But once we'd overcome that barrier of learning, it's a relatively straightforward process to go through. So I guess the thing I would encourage is, and the takeaway from this is that once you understand the process involved, it's relatively straightforward to fill those gaps where there's not an out-of-the-box management pack for either a third-party piece of software or something you've written yourselves. So you can get that full end-to-end experience. Cool, so agenda for today, quite a lot to cover, but we'll just walk through our basic project experience, so going out there, understanding the system architecture, how we went about designing the monitoring solution, the building of the management packs themselves, so that's where the demos are going to come in, working with Operations Manager, and that's going to cover a bit of the PowerShell interaction with Operations Manager. And we'll also talk a little bit at the end, if we don't run out of time, about the benefits that we see. So we appreciate that this is effort you have to put in to build these management packs. If you're putting in effort and you're expending resources in your organization, you're going to want to understand what the benefits you're going to get from that are. Okay, so we'll kick off with understanding the system that you need to monitor. So basically what you're going through here is a typical discovery process. So you're looking at talking to the software architects involved who own the system from a technical perspective. You're working out what the technologies they've used in their architecture are, so whether it's ASP.NET, BizTalk, SQL, etc. And you're really looking to get the technical expertise in those technologies. So ASP.NET has a number of performance counters and instrumentation options that you can turn on or to a greater or lesser extent. Again, also in web services with WCF and ASMX, there's certain performance counters that will give you a very good understanding of those technologies. And you're really looking for the people in the organization who understand those performance counters, the life of those performance counters, whether they are cumulative over the day before IIS gets reset or their worker processes get reset, or whether they are averages over minutes, seconds, etc. You're also looking to identify the key people from a business perspective, the people who are accountable for those systems, because they're going to be the consumers. So those are support staff, they're business owners, they're the technical design team who are responsible for making improvements to the system. And generally, the question you're going to ask those people, I mean, this is a monitoring solution that you're targeting, so one of the questions you're going to ask is, what proves the system's healthy? That's a really short question. It's a really simple one to ask, and our experience has been that it's a really hard one for people to answer. So don't get your hopes up, is that last bullet point. That's really why you're looking at those key technical people who understand the technology, because really what you're most likely going to end up doing is putting in a best practice approach to start with. You're going to start capturing those metrics about the application and then analyzing them and then determining what makes it healthy over a period of time. So this, and I guess that's one of the other things that you can probably take away from this, is that it's not a project-based solution where you start off with no monitoring, you get to the end and it's perfectly monitored and you're going to capture every incident from then on. It's really something that grows and matures over time. Cool. So when we went out and asked our infrastructure engineers and our software architects about this internet banking solution that we run in Kiwibank, the engineers gave us a diagram like this and said, yeah, if you can just monitor that, that would be awesome. It's relatively complex, but it's also probably a very familiar architecture to a lot of people, where we've got multiple sites, we've got firewalls, partitioning zones in our environment, we've got web front-end servers, if I can work this pointer here. So we've got web farm that hosts the website itself. Internally, we've got enterprise services that sit on web servers, so those are a mix of ASMX and WCF services. We've got core banking systems that exist in our system. We actually have multiple core banking systems. So we try to be a fairly low-cost bank. So we tend to take specialized smaller systems to run, like our card platforms, our transactional accounts, etc. And then we've got basically some support things like document management servers and database servers sitting behind these. So relatively typical, and when you break it down, it becomes relatively simple. From a software perspective, we got a fairly thick and complex software design document from the architect. But from reading that document, we were able to determine the main components that make up the internet banking application. So we have 3 websites sitting out in our DMZ, and we've got a session cache that allows us to share our session state across our web farm. In our middle tier, in the services web servers, we run both application or channel-specific services and also enterprise services that are shared across all of our customer experience touch points. On the database side of things, we've got background Windows processes collecting audit information, putting them on message queues, pulling them off, and storing them in databases. And all of that's really a front end and the user experience component against all of our core banking systems, some of which we host and some of which are hosted around the world. Cool. Right, on to designing the monitoring solution. So within SCOM, there's two concepts called the service model and the health model that we'll talk about here. And we'll also look a little bit at some of the design that we did within our internet banking solution to take those concepts and apply them to our internet banking. So service models and health models. Basically, your service model is a description of the components within your environment that you want to monitor. So it could be servers, network switches, it could be Windows services or software components, websites, etc. So those are the components. They're about how those components relate to each other, which ones depend on others, and also how do you go about identifying instances of these components within your environment. And we'll talk a little about the classes, relationships, and discoveries when we do the demo. But those are really the concepts within SCOM that allow you to describe this service model. The health model is looking at how you determine the health of those components that you've described. So those may be driven off of performance counters, events, rolling text logs, database tables of logging. And those are really described about the unit monitors are going to be the ones that go out there and collect that data. Aggregate monitors are a way to roll up the health of lower level components. So you might have, so in our instance, we've got 4 web servers on our front end. We may just want to send a warning message if one of them fails, but if 2 of them start to fail at certain points of the day, it may become critical. So those aggregate monitors allow us to do that. And dependency monitors are really there so that you can leverage existing monitoring in existing classes. So IIS websites have an availability monitor, and when we specialize that website for our internet banking websites, we can pull through that availability monitor from the IIS website and not have to write it again ourselves, just through writing a dependency monitor.
Key aspects about your health model is that it's broken down to several things such as availability. So you can target things which affect availability of that component. You have configuration, so if your configuration slides, changes happen in the environment. You also have your performance. Obviously, anything that's performance related, you would target things against the performance aspect of that component. And then the last but not least, you have security. So performance and security underlining, configuration and security underlying your performance and availability of those applications, components.
Cool. So a sort of small section of what we did in applying those concepts to our internet banking solution that you saw earlier. In the orange are classes that we identified that we wanted to create within our service model. The white lines show the relationships between them. And the grey classes are existing out-of-the-box management pack supplied classes that we could derive our classes from. So one of the key concepts in SCOM is that every class has a base class, and you can't really get away from that. They all kind of nest back to an entity, which is a very generic single property class, and then everything's derived from that. And that's really just a way of leveraging existing monitoring property definitions and class structures and relationships. And those base relationships also pull through all the monitoring from that base class through into your class, so you can leverage that again. From a health model perspective, so again, you see that there's already an IIS website which has an availability and an IIS app pool. Those aren't the real names, by the way. They were fairly lengthy and couldn't fit on the slide, but I can give you details of those. But we were able to leverage, by putting a containment relationship in our class, to pull through the monitors that exist within those websites and pull them through. Similarly with the Windows Server computer, because we could put a base class relationship between our web servers and database servers to there, we were able to leverage all the existing monitoring that exists within there. And also when we look at performance views and health state views. We get all the benefits of the monitoring that exists already in that base class, and it comes through into our web servers. And then all of those components that we have there roll up into an internet banking class, which is really representing the IT service itself. So that can have a health in itself, and the health of that is determined by the relationships across all those existing and custom described classes. So just introducing the concepts of a service and health model there, and give you a quick look at some of the application of that against Kiwibank.
Just one thing before we jump into that. Obviously, we've gone through the design there, and the design also encompasses the fact that maybe in the future you want to use these things that you discover, these class instances, in some sort of ITSM tool, such as Service Manager out of the System Center suite. The work that's actually being done here has taken into consideration the design of that, so those class instances and related classes and relationships, etc., can be imported easily into your System Center Service Manager suite, and then you can start utilizing those as CIs with your ITSM processes such as incident change, etc.
Cool. So next section we're going to talk about is building the management pack. So we'll do quick 101 on exactly what a management pack is and what comprises a management pack. We'll talk about the tools that you use to create management packs, specifically the ones that we've selected for Kiwibank's implementation. There are a range of tools you can use, but we narrowed it down by a process of elimination, and I'll describe what those are and why we did that. Now I'll give you a little bit of a demo and just really walk you through the configuration and the process that you go through to create a management pack and deploy it into System Center Operations Manager, and then how you can see those classes being discovered and visible within Operations Manager. Okay, so what is a management pack? So management pack is just a container of configuration information, and that configuration is described within XML structures. You have a class, and the class, so the classes, discoveries, and relationships really form that service model that we talked about. So the classes describe the components, so you've got sets of properties that you can populate to describe those classes. The discoveries are the mechanism by which you go out into your environment and discover instances of those classes. Those are VB scripts, registry probes, PowerShell scripts, etc. And the relationships are really once you've discovered objects, the relationships are how you link those objects together, the relationship between them, the dependencies that they have on each other. Groups, monitors, and rules you're probably all familiar with. So groups are really just a way of taking the objects that have been discovered and grouping them together so that you can manage them as a single entity. Operation Manager is very focused on you select an object, a discovery, a rule, a monitor, and you act upon it. That can get very repetitive, and groups are a way to shortcut that and apply those changes to the configuration over a range of classes or object instances. Monitors are a way to affect the state of your health model. So those are the things that will help you change it from healthy to warning to critical. They can also fire alerts, which can be pushed through to your incident management system. At the moment, we don't use Service Manager, but it is the intention to use it in the future. But we can still push through those alerts through to our existing service delivery tool. Rules are a way to capture data. So that allows you to report and trend over time about what's going on. Rules can also create alerts, but they don't affect the state of your objects at all. Rules are really helpful to capacity planning, etc., within your environment, and also when you're looking at incidents to see what's happened over a period of time leading up to the event that's happened.
Think of the rules. I see this in a lot of organisations. People get confused about monitors and rules and with regards to alerting and that, but just think of rules as, like David said, as performance collection using such as tools like perfmon, but on an enterprise-wide scale, and centralising that information into your SCOM environment to a central database. So key aspect difference between a rule. It collects things, monitor generally just changes the health state of an object.
Cool. So those are the components that make up a management pack. The tools that we use to create that XML configuration and to work with it with an operations manager. Primarily are these 4 tools, but yeah, I mean, we always end up falling back to Notepad occasionally as well. So Visual Studio authoring extensions are a plugin to the Visual Studio IDE, which gives you a lot of IntelliSense, templates, code snippets, etc., which basically give you your first step on the ladder to creating these management packs. It also breaks it down into very simple steps and gives you, in some cases, almost a wizard-driven approach to creating them. Operations Manager Console, that's really just around the standard things that you do normally with your out-of-the-box management packs, so overrides, creating rules, monitors, running tasks, looking at views, and verifying that those discoveries are actually working, which in some of my classes took a little bit of investigation, but we'll cover that later on. Yeah. Cool. You want to cover the PowerShell?
Great. Okay, so PowerShell is obviously quite widely used out there. If you don't know it, get friendly with it. So we utilise PowerShell for some real low levels of things that you can't really easily get out of your SCOM environment through the GUI, and maybe you don't want to go and interrogate the database. So we can use things, the PowerShell commandlets that come with SCOM for getting class properties, which is quite useful. Finding out actually what your classes are out there, your rules and your monitors, etc. We also use PowerShell in our scripted discovery processes. PowerShell exposes a lot of good methods for identifying components out there, so very, very useful. In some respects, a lot simpler than maybe using VBScript, etc.
There's definitely a sort of sliding scale on a performance perspective about your discoveries, with registry probes being the quickest, VBScript being the next, and PowerShell being the heaviest from a performance perspective.
As long as you don't put loops in, right?
Yeah. But you have to remember that these discoveries may be running only once a day, once a week, maybe every 4 hours. So if they're only executing for maybe 5 seconds, 10 seconds on your machine, it's not really that much of an overhead. What you really need to be thinking about from a support perspective is what skill sets do you have in-house? Do you want to standardize on one technology over another? And then write those PowerShell scripts or VB scripts accordingly. MP Viewers, sort of free community-based tool, which basically allows you to look inside sealed management packs. And sort of sealed management packs versus unsealed management packs we'll cover a little bit later on, but basically sealed management packs, you can't change what's inside them, and the unsealed ones, you can create new rules, monitors, etc., and store them within those unsealed management packs. But MP Viewer is a great tool for looking at the out-of-the-box management packs that you get, looking at the classes, identifying what key properties are on there that when you're discovering and you've derived from one of those classes, you might need to set a certain key property. So key properties are mandatory properties that have to be set. If you've inherited them from a sealed management pack that already exists, you need to identify them, and MP Viewer is a great tool for doing that.
One thing you might notice out there, we haven't talked about the other tools that are out there that you can use for authoring your management packs, and that's the likes of the Visio Management Pack Designer. It's a bit limited in respects of what you can do around discovery. Also, it's in CTP, not an RTM supported product. The other option is your Operations Manager Authoring Console 2007. Big caveat with that is if you go and export a management pack out of your 2012 environment, you're not actually going to be able to open it up in your 2007 authoring console due to the schema changes. So we went through a range of investigations to see what the best tool was, and certainly the Visual Studio authoring extensions was the money. Just remember, only supported on Visual Studio 2010.
I guess also we probably standardized on Visual Studio because we were really a collaboration of development and infrastructure engineer backgrounds. So I come from a development space and worked up through an architecture role. and Brian's more coming from the infrastructure side. And that collaboration when you're looking at monitoring an end-to-end IT service that comprises both of those functions is really important.
I think they call it DevOps, don't they, or something?
Yeah. Cool. So right, let's get into a demo.
Ooh, worked.
Yeah. So in this demo, what we're really going to do is, I'm not going to stand here and type in a whole load of XML, which would get relatively boring after a while. But what I'll do is just walk you through the key components that we've talked about, show you them in the XML, and describe the main properties within that XML that you're going to work with to configure things. So when you install the Visual Studio authoring extensions, if I just go File, New, Project, it adds in this management pack set of templates, and you get templates for Operations Manager and Service Manager, both of which use management packs to describe their classes and objects.
Yeah, the underlying technology that Service Manager uses is very, very similar to Operations Manager. Some of you out there, if you've used both, you'll recognize that.
Yeah, and you get a couple of project templates really describing whether you're working on an existing 2007 management pack and bringing that into Visual Studio authoring extensions, or whether you're creating a new one. There was a XML schema version change between the two, but they're backward compatible, so you can still work on your existing 2007 ones within Visual Studio. So what I did when I basically went through and created 3 projects for this, and this is a standard design pattern that we use within our monitoring. So we create 3 projects, a library, a monitoring, and an overrides. And the library and monitoring end up being sealed management packs, and the overrides is the unsealed management pack that we use for the operational staff to make day-to-day changes to the monitoring, so overrides, temporary rules and monitors that are needed to support incidents, etc.
You'll see that inside your SCOM console and your management packs list, where you're replicating the use of the term library, discovery, and overrides.
Let's over and show you. Yeah, so there they are there when we import them. So we start off with our library management pack, and that library management pack is really the container for the service model that we designed. So it's got our classes, it's got discoveries, and it's got the relationships described within it. What we've done here is just created a mock example, and you can get this code, you can download it from a SkyDrive, and we'll give you the link to that at the end. And it targets the print spooler service in your environment, so you can actually run it in your pre-production and dev environments if you want to have a walkthrough of it and see how it actually behaves in practice.
Why not production?
Yeah. Because, I mean, this template is really something that we just basically replicate again and again for within our environment for the different objects that we want to monitor. So it's a good starting point. There are other templates out there that you can download as well from Microsoft. So from a class perspective here, we've got an application server, which is a specialized version of a Windows server. So within the XML, the key parts that you're really looking at are this section here. So what this is describing is the class itself. You're really just giving it a unique ID, which will exist within SCOM, and that needs to be a unique ID across all management packs. So it's across your whole management group. So you really need to think about your naming standards to make sure that those are unique. It tends to be that you will you'll describe it as your company name, the IT service or component, the IT service specifically that you're trying to monitor, and then maybe the component name itself. So you want to sort of structure it in a consistent way to make sure that it's unique. The base class, as I described, every class within SCOM needs to inherit from a base class, and in this case, we're specializing the Windows Server component. We're making it public because we want to use it in our other management packs, and it's not hosted. So the hosted concept is, if you think about a piece of software, you install that on a server. So that software component becomes hosted by the server. A server itself isn't hosted by anything, so in this instance, the hosted is false. And the singleton is false. So singletons are very rare within SCOM, but that really means that there's only one of these things that exists within your environment. So like a root management server, for instance. Then the reason that we specialized this is we wanted to add on an extra property. So this is very similar to the attribute concept within the Operations Manager console, but a lot more powerful when you do it within Visual Studio. So within the Operations Manager console, when you talk about attributes, you're limited to registry and WMI discoveries for the values of those properties. Within Visual Studio, you can really use anything. You can use PowerShell, you can use commands, line parameters, you can use really anything you like to discover what those property values are. In this case, we've just added on a role type property. So what we're going to do is describe there the main purpose that this server holds within our environment.
I think one key thing here is to understand it's not scary C# code. We're using Visual Studio here, and we're just cutting away at some XML fragments. So for a non-dev, reasonably comfortable, right?
Yeah, although it's a development IDE, I mean, you could write this in Notepad if you wanted. Basically what the Visual Studio IDE and the authoring extensions give you is that it gives you IntelliSense. So it helps you put in comments, describes what you can describe within that container. So within a class, we can describe properties. So it's really a much more productive way to write that. And it'll also, when it compiles it, it'll give you a good description of where you've got it wrong.
Very handy.
Which Notepad obviously won't.
Yeah. All the syntax in there is well documented on TechNet. So just jump on there if you need to know some of those attribute commands and what have you.
Cool. So that class is really where you're describing your component. And then the language packs down here, if you need to be concerned about multilingual display within your SCOM environment. So a lot of the vendors' management packs will have German, French, etc. Described within the language pack. But in our instance, we're really just interested in the English version of it, so we tend to just have the one language pack described. And this is really where you're taking your unique IDs and you're saying within SCOM what will be displayed when you're looking at that class. So on your targets list, when you're doing your discovered inventory and you're scoping things, that's really the text that will be displayed there. And then when you're doing it for a property, you're basically describing the class. The sub-element is the property's unique ID, so you can see that up here. And then you're just looking at the text description for that property. So all relatively straightforward once you become familiar with it. Hence the example, and that's why we're giving you the code. The difference with the component. So by the way, these MPX files are management pack fragments. So when you right-click and go Add a new item, you get all the different components that make up a management pack within here. So you can see classes, discoveries, groups, etc. Script files, and basically everything you need to construct your management packs are there. Within the component, the class description is very similar. Again, unique IDs. The difference here is that in this case it's hosted because it's a Windows service we're talking about, and it's going to be hosted on the server that it's running. We've got a few more properties that are specific to a Windows service. And the difference here is we describe the relationship. So this is the relationship between the Windows Server instance and the instance of the Windows service that we're monitoring. So here we have the source is the application server, and that's just the unique ID from our application server. And then the target ID is the ID of the software component that's being hosted by the server. There are a few different types of hosting relationships. So you can have the hosting, you can have containment relationships as well. The containment relationships are really where you want to pull through dependency monitors from an existing class. But in this case, Windows services aren't monitored by default, so there wasn't any need to set that up. So next thing after looking at the classes, how do we go about discovering these? So if you're familiar with Visual Studio, it quite often gives you these containers for properties to help you work through describing the discovery. And really all it's doing is it's a front end to allow you to set a number of properties around the discovery. So remember, discoveries are the things that we're launching out into our environment to go out and discover object instances of our classes that we've described. So here we have to target where those discoveries are going to go. So we try and scope those as tightly as possible. You don't want all your discoveries going out to all your computers in your environment. So that's another reason for creating our application servers, is it gives you a fine-grained view to target your discoveries to. And then we can just create a group of all the application servers, and it's quite a simple way of doing it. You look, again, everything's got a unique ID, and you just follow the same naming principles, where it might be your discovery, your service, your component, and the type of discovery that you're doing. Next important thing to look at is the classes that are going to be discovered. So you need to tell the discovery what type of data is going to be returned from the agent when it's discovering things. So in this case, it's a discovery that's going out and going to be returning an instance of my component. Right. Next thing you want to do is select the type of discovery that you're running. Yeah. I'm running over already. So types of discovery, so you've got VB script, PowerShell, registry, probes, WMI queries, almost anything you want, especially when you've got things like PowerShell and VB script and you can run command line from those. You can really get a fairly rich process of discovery. You may end up writing multiple discoveries for the same class as well. So we had instances for our IIS environment where we've got IIS 6 and IIS 7, and we don't run IIS 7 in compatibility mode, so we'd standardized on PowerShell for our discoveries, but we couldn't run that against the IIS 6 environment, so we had to write VB scripts discoveries for the legacy environments. And that type of discovery that you select specializes this configuration XML. In the configuration XML, you're describing your frequency that the discovery is going to run on. You're describing the name that the agent will use to create a temporary file for the discovery out on the instance of the target. You're passing in a set of properties into your script. So those are things like the ID of the target, the container for the management pack element that you're going to return, etc. And you can pass in anything you like into there. And then you can actually write your script body in here, but this is probably about the worst environment to try and do that within. So generally what you'll do is you'll create a script file independent of this configuration and then just reference it in here. And when the management pack's compiled, it'll substitute that file into there and transfer it out to the agent. Cool, so I'll just show you quickly one of those discovery scripts. I'll show you the PowerShell one because it's a lot more concise. Here you pass in the parameters, and generally you always pass in these 3 parameters, so it's a very repeatable process again. And there's a lot of information about what those are up on the net. We describe our script name so that when we're logging, it's very clear within the Ops Manager log what script's actually writing out there, because sometimes it's quite hard to understand where your scripts are running within your environment. We then, down here is the really interesting bit. Well, interesting from my perspective. What you're basically doing is you're creating a property bag here of the data that's going to be returned. You create an instance of the class that's been discovered. You set the properties on that class. So remember, we were talking about key properties from inherited classes. So in the Windows computer, there's a principal name that's a key. So we have to set that. We set a display name for it, and we set our custom property that we added to the application server. We add that instance of the class to the property bag that's going to be returned. And then just down at the bottom of the script, from PowerShell perspective, you're really just outputting it to return it. We put quite verbose logging in our scripts, and you can tune that with by putting registry settings on the target servers, etc., depending on whether you want to output the logging or not. But in this instance, we'll just output the logging all the time.
One of the benefits of using PowerShell scripts is if you're concerned about security, you can obviously sign them and have them loaded in here. As David mentioned before, out on your client device, the script is going to get extracted out. And if there's a VBS script out there, you want to make sure it doesn't get touched in the middle. Obviously, by signing a PowerShell script, it'll just prevent that from happening because it won't execute it if it doesn't match.
Yeah, we're running a bit tight on time, so I'll not cover the monitoring in a great deal of depth. Just be aware that you can describe monitors within this environment. When you create a monitor with an ops manager, this is really what it's creating within that unsealed management pack that you store it in. Generally, what we'll do is we'll create them within Ops Manager into an unsealed management pack. We'll export it, bring it back into Visual Studio, and then tidy it up within there. The reason that we tidy it up is to follow our naming standards, so that when people are editing these things in the future, it's quite easy to reference and to understand what's going on. From the SCOM generated one, this sort of user-friendly bit of text here that describes what we're doing would just be a GUID. So it's very you're constantly jumping between the language pack to see what the description is and what the GUID is. It's also easy once you've created one within Ops Manager. That's quite a click-heavy process to go through, and you can only do one at a time. Within here, you can simply cut and paste that block and repeat it and just change the 2 or 3 properties that you need to if you're wanting to create a lot of these monitors. And then if we go across to Ops Manager, so that's the end of the Visual Studio part. The overrides management pack there is just empty. We just create it within Visual Studio so that we can retain the consistency of naming and IDs, because Ops Manager will force you down a certain path. Within Ops Manager, you're probably, if you're running Operations Manager already, you're probably fairly familiar with this process, so we'll be fairly light in this area. But really what you do is you're just basically importing those management packs that have been created in Visual Studio. Oh, I should have shown you, actually. To create those management packs, relatively straightforward. For the sealed ones, to seal them, you're just looking at the project properties, going to the Build tab, ticking the Generate a Sealed Management Pack for this project. You select the key pair. So a key pair is just a public-private key pair file that you generate with the sn.exe tool.
Comes with Visual Studio.
Yeah.
Yep.
Or the Windows SDK. Don't really need to worry about too much what's in there, but you just need to generate a file for your company, probably, and make sure you never lose it.
Put it in the safe. Yep.
Because the public key from there is going to be included in all management packs that reference your management pack. So you need to make sure that it's consistent, that you reuse the same key again and again so that you don't end up in an operational nightmare. And then it's just simply a case of right-clicking and doing build, and that'll generate your management packs. So if I just quickly jump out here and look in the output folder, the MP file is the sealed management pack. Excuse me. The PDB is the debug information, and the XML is an unsealed version of that management pack. Should you want to go in and look at the version numbers, etc., that have been applied to it. So within Ops Manager, it's just a case of right-clicking on there, importing that management pack, which you're probably all familiar with. We've imported our 3 management packs here. So those of you that use Operations Manager on a day-to-day basis, you understand that there's quite a time delay in things happening. So for the interest of this presentation, we've already enabled some of our discoveries. So the process that you would go through would be to, once you've imported the management packs, all of our discoveries and monitors are disabled by default, basically so that we can control the enablement of them and make sure they're targeted correctly. You'd basically go through here and you would create an override for the discovery and target it appropriately. In this case, we've overridden it for 2 of our servers, and we've increased the interval, mainly because we were doing this as a demo perspective. Generally, those frequencies would be about 4 hours to a day. That enablement of that discovery, after a period of time, will bring through an instance of those application servers within the environment. I've gone way over, haven't I? And the enablement of the component will we basically target our application server instances that have been discovered and enable it for those. And within here, okay, for those 2 application server instances, we've got an instance of our Windows server, our print spooler service.
I think one key thing that David just touched on, excuse me, there was the overrides and enabling those. Out of the box, SCOM will have things turned on and SCOM will have things turned off, and quite frequently I see people going into a performance view and going, well, why is there no data on that graph? Not everything is enabled out of the box by default. So just be aware of that, and I'll show you something soon where we can see what is enabled and what isn't in a script. Cool.
And when you first create these classes, you may not have any monitors against them, so it'll just be a green circle with no tick or any state within it. In order to get that tick or whatever the health state is of that object, you really need to start enabling some of the monitoring. In this case, we've just written our is the service running or not monitor. And that's the only thing that's providing our health at the moment. But we'll look at some more complex examples a bit later on, maybe, if we've got time, which we probably won't. Cool. So that's the end of the demo part of it. Right, so what we covered off quickly in that section was what's in a management pack, so the classes, monitors, discoveries, rules, etc., the tools that we use to create them, and went through a quick demo of looking at the classes, discoveries, the deployment into SCOM, the overriding of those discoveries, and the monitors and rules. We didn't create the monitor, but we showed you the monitor description within Visual Studio itself. And I showed you that monitor coming up in the Health Explorer.
Great. Thanks for that, David. Me being an infrastructure guy, I'm actually not too scared about that whole thing with respects to Visual Studio. A bit of XML here and there. It's all good stuff. So what I'm going to talk you through is obviously to support what we've just developed there. Sometimes the GUI doesn't really give you the information that you need easily. So obviously scripting processes are fantastic for doing that, and PowerShell, SCOM includes a PowerShell module, which you may already hopefully be aware of. So what we're going to go through here is just some useful PowerShell commandlets which have helped support us through the processes. Talk about discovery, targeting, and troubleshooting options. That's really key. Nothing worse than going, well, where is my object? I've got something that should have run. What the hell's gone on here? We'll have a look at that. And then some useful reports. I tend to find that people steer away from reports and sit in their ultra-flooded alert view, and that's as far as they get in life. So some useful reports which will actually tell us what our management packs are doing out there in the environment. Press that one. Okay, so some of the useful PowerShell commandlets, and obviously you'll be able to download the slide deck, so you won't, I won't go through all this information right at this point, but we're going to jump into a demo and just utilise some of these here, very, very useful commands. So we're just going to jump back into our demo environment, and what we've got here is the PowerShell ISE. I'm assuming you're familiar with some sort of PowerShell. And what I'm going to talk about here is just the key things in the SCOM environment with regards to PowerShell. Obviously, we've got our module, the Operations Manager module here. And I'm going to go and get some classes. And as we saw in David's demo within Visual Studio, we defined some classes. So we can use PowerShell quite quickly here to go and run a command to get all these classes that started with our prefixed option, which was TechEd with a wildcard off it. So bang, we see those in there, fantastic. We can see the management pack name that they're contained in. So very useful if you know a class, but you actually want to find out where it is in terms of management pack. You get the unique ID, that can be very, very useful as well, because some event log messages you may see with your ops man will reflect to an ID. This can just make your life a wee bit easier to find out what they are, not easily exposed in the SCOM console. So we've got those two classes, and from your classes, the discovery process kicks in and then creates class instances. So what we're going to do here is just target a specific class and then get all the class instances, and we can just output that in our PowerShell ISE here. And we see we've got those two class instances, sorry. And as we see, the health state successful. Well done, awesome. Not in maintenance mode, so we've got a fairly available system here. And these are the display names there of those class instances that have been discovered as part of the discovery process. So very quick to get that information. Now, thinking that you can use PowerShell to do this, well, then you could use other systems to get this data out and have a bit of a mashup potentially of maybe monitoring solutions in the environment. The world's your oyster in that respect. Then ultimately, what we're going to do is just focus in a lot deeper into one of those class instances that we discovered, because there's a significant amount of information sitting behind that. And as we can see here, we're just targeting and having a look at one of those specific instances, and you'll see some of these property fields which have been defined by their class here. So we're getting obviously the property fields over this side here with the respective values here. And you can see there's quite a lot of information stored in here. And again, if I just go back to a bit of Service Manager 2012 integration, this is the same thing you would see over in there when you get that connector in place. So very useful in your ITSM processes. So this gives you the ability to find out some cool information such as that ID and various things which aren't exposed through the Operations Manager console. I also like Service Manager, by the way. So that's some useful classes, class-related PowerShell. Now all these PowerShell samples are available for download. And the SkyDrive link, which we'll get at the end. Now, relationships. Everybody wants to get a relationship, right? So the relationships effectively, like David said, glue things together. Now, you can't really easily see a relationship instance in the environment through the tool. I mean, you can look at the Health Explorer and you see something sort of linked up, but sometimes you need the ability to be able to actually see what they are. I mean, you could jump into the OpsMan database and have a look at that, but this is just a wee bit easier. We use a get SCOM class. We want to get this class type, and then we can get the relationships that are configured to target those class types. And then we can, based on then having a look at a specific class instance, find out its relationships. So we can run this piece of PowerShell code here, and we can see here's a very basic view of that one relationship that's been defined in Visual Studio. Then we can go and run this next piece of code here, and what that will show is, well, here's the relationships for a specific class instance, and fairly simply, you've got a source object, which was the Windows server from memory.
The application server.
The application server, and then our actual component. And this is a relationship record in its own right. And these things, particularly in Service Manager, actually show your relationships between these components, and obviously in SCOM affect the hierarchy of the health. Again, some useful stuff there around getting the ID of that particular instance as well. So we're getting quite lowly on deep in here, but these are things that are very, very useful when you start going down the line of creating your own management packs. Now, I'm really rabbiting through here because the clock's rocking. Right, discoveries. What is actually out there in all your management packs, all those discoveries? Now, this is a bit of XML that I just whipped up on PowerShell that I just whipped up on a Sunday afternoon. What we can see here is we can see our two discoveries that we've created in Visual Studio, and you get a lot of raw information. I'm just using the output grid view part of PowerShell, and you get all the property values here, and you can see, oh, we've seen this before in Visual Studio. Cool, we can see those specific discoveries prefixed with TechEd, and that's just using the get SCOM discovery. Then what you might want to do is, well, let's go and have a look at all the, whoopsie-daisy, the discoveries that are in your environment out of all the management packs, and bring in through the default frequencies and things like such. So I had to get a wee bit crafty in there. I'm not a PowerShell guy. It's probably a better way to do it. If somebody could tell me, that'd be great. But what we've got here is effectively a list of all our discoveries in our SCOM management group, whether they're enabled out of the box by default in their default interval setting, the management pack, and then what the target class is. This is key to understanding how busy your SCOM environment's going to be, because if a discovery runs, it's going to send a packet back to your management group. Your management group servers are then going to go process it, chuck it out of the database. Now, if you've got, I don't know, 30-odd discoveries doing this every 60 seconds, you're going to have a very, very, very busy SCOM box, and the database is going to get thrashed, and the DBA is going to get a bit angry. So this is a useful thing to be able to see globally what's running in that system. And you'll see there we have discoveries that run on various targets every 60 seconds, right through to over a day, and then for some reason quite a significant period of time there. Not sure what that one's all about. So that's a very useful piece of script, again, downloadable later on. The other thing is rules. As we touched on, rules collects data. So you might say, hey, I want to know how much percent CPU usage is happening on a particular computer at a time. And then you think, oh, great, I'll create a rule up and do that. And I'll target it to these group of machines. And then 6 months down the line, you've sort of forgotten about that one. You think, oh, I need to do this for something else. You go and create it again. Ooh, you're duplicating your information in your data warehouse here. Probably not the best thing to do. So this piece of PowerShell code here is using the get_SCOM rule, and it's simply just utilizing this piece of highlighted code here to query on a percent free space counter, which you would see through your perfmon tool. And when I run this, what this shows us is the rules that are currently in the system, which are targeted to that perfmon counter. So that tells us, hey, we've got a 2012 counter here, and it's doing the logical disk, and we can see there's one already in play. It's enabled, cool, so we're actually already collecting that information for 2012 boxes, so we know we don't need to go and recreate that. You don't want to go blowing out your database. And the same thing for monitors as well. You can do a monitor based on the counter as well, and that will just simply show you what monitors are in play, which are targeting the health of something or other. And you see this is enabled by default, so all you would need to do is, instead of recreating it from scratch, chuck an override in there and enable that thing. Don't re-engineer the world. Now, just quite a useful one. Now, there are some third-party management packs which you can bring in and get this information with, but this is one reasonably quick and clear piece that I like, is just finding out actually who's connected to our management group. When you go and put your SCOM server in, your first one, it's part of a management group, and everything's performing well. And then 12 months later, you're giving a whole bunch of people access to various SCOM consoles, and that's going to impact on your management group servers. So you may need to scale them out. So it's quite useful to find out who's connected here. And as you can see, we've got that MT authority guy. He seems to be everywhere. We've got our administrator, and we can see that we've got some people monitoring our monitoring solutions. That answers that age-old question, right? So, Prism.
The naysayers around Ops Manager are always asking who monitors the monitoring solution.
Yeah, so I don't know who that guy is there, but that can be quite useful, and you can't easily find that information out through the GUI. Right, so that was pretty quick on that, so we'll just keep rocketing through here to the next slide. Whoopsie daisy. Apparently arrows don't work. Great. Discovery, targeting, and troubleshooting. So I'm going to really go through this one like a rocket. But a 101 here. You're going to go and try and discover something out there. You've got some management packs. Why isn't my thing being discovered in my inventory? Well, is the SCOM agent actually running out there? So first thing to check, is it actually installed? Probably. Confirm you're targeting your discovery. If you have a class out there that you're targeting your discovery to, but there's no class instances of that class type, your discovery is just not going to do anything. So check out your target. If you're not familiar with targeting, get on TechNet and start learning about that. Obviously, the security context of the SCOM agent is important here. If you've got a security guys and they say, hey, you need to run this as a real low privilege user, it might actually prevent your discovery from running, okay? Pretty standard sort of stuff. Environmental things that could impact your discovery processes, firewalls, hard and OS builds, etc. Also, the components that are on the server that you may need to use. Does PowerShell exist on there? Your PowerShell discovery may not work. And also scripted discoveries. Use your event log for error logging, as you saw that in David's code there before, and that will make life really, really easy. Some useful reports I'll quickly go through here. So data volume by management pack. These are under the System Center core reports section. They'll actually tell you what is your management pack in terms of data and volume of information that it's generating, and also by workflow and instance. When you see the term workflow and anything SCOM related, that's actually a discovery. In Service Manager, they call a discovery a workflow. They change things around. Generic report library, overrides is key. You want to know what overrides are in there. You want to know if there's somebody out there going turning things off in your environment. Check that out, or maybe just revoke their access. Most common alerts, everybody's got a clear alert pane, right? No noise, sweet. If you have got a lot of noise, you want to get some factual information about what is the most common alerts, review that one, and also configuration changes with respects to properties. Property changes through discoveries. Now, summary, working with SCOM. Get to know your SCOM PowerShell commandlets. Don't be scared. There was a good session yesterday on a bit of a fair around PowerShell. Get out there and download that and review it. Understand your discovery targeting options, discovery targeting and also your options for troubleshooting, and take time to understand those built-in reports and use them. Right, I'll hand it back to David and have a rest.
Cool. Right, yeah, I rushed by then by running over my section, so apologies there. I realised that we're getting a bit close on time. This section is just going to take about 5 minutes, and then you can come up and ask questions at the end. Basically, if you're going to want to expend effort in doing this, you're going to need to see some rewards for it. So I just thought it'd be useful if I just talk through some of the features within Operations Manager that we're using and the benefits that we see from them. So monitors and rules, you're probably using those across your existing management packs. What we're seeing by actually targeting them specifically at the software components and using the language that is commonly used within our environment for those components, we're really able to give the operations staff and the support teams a concise view of the things that are really important for them to be looking at. If you look at for instance, if you look at the monitors in the Health Explorer of a Windows server, there can be hundreds of monitors targeted at that. If you can specialize that a little bit and just give them the things that are really important within your environment, it's a really helpful thing for them. Synthetic transactions. So we've started using synthetic transactions to hit all our public websites. So we go out onto the public internet, we come in. So a synthetic transaction is basically a scripted, recorded session from a user. So it's trying to simulate a user action on your website. So we can go onto our website, we can log in through our authentication processes, we can navigate around our site and perform actions on it. All of those HTTP requests are recorded and have performance counters associated with them, so we can actually trend the performance and availability of our site over time. A lot of the output from that is really targeted towards capacity management team and also the business owners for those services. APM, we've been using that in our pre-production environment at the moment, not in our production environment. So we'd done some significant changes in our enterprise service layer from a compliance perspective. And, thank you. And we were keen to understand what performance impact those changes had made. So we started doing the traditional view of doing some network tracing on it. Those network traces showed some anomalies because we'd increased the number of SQL queries that were going on. And it showed us a bit of a change in pattern on performance for those particular web service calls. Because the network tracing had identified the issue, but it wasn't able to look into the code, we used APM to then analyze those methods, and we could actually see the full stack trace within the .NET code without doing any changes at all to the code. We basically just pointed APM at that web service, enabled the entry points, and then the depth of tracing that we wanted within there, and set a few thresholds. That was able to give us a view of the code. We then worked with the developers to identify where the issues might be. And it turned out there was some transaction scoping within there that was causing some issues around connection pooling. With a move to the entity framework to manage those transactions a little bit better for us, we were able to see a significant improvement in the performance, and we could show the performance before and after in the pre-production environment, so we had confidence when we pushed it to production that it would give a positive impact, and that's shown about a 30% saving on the CPU and a significant saving in memory and throughput as well. So the physical benefit of that is that we can actually scale back on our server infrastructure within that middle tier. So it's got a real money benefit within the environment, and it's a good sales point. So finally, the SAVision side of things. So SCOM's great once you're familiar with the environment and you're looking at the very detailed views of things, but it's not great from an entry point and looking at the service as a whole. There are distributed applications, but those aren't that friendly within the SCOM console to look at. So we use a third-party product called Savision to visualize the monitoring that we do. So this is a top-level dashboard of our IT service, internet banking. So we can see from a sort of DNS routing perspective which site is active. You remember from the infrastructure diagram we had 2 sites. We've got our dashboard elements for our front-end servers, our middleware, and our database, and all our physical infrastructure that's monitored. And this is really a great accessibility point. So you can get you've got a very complex environment. You can roll it up into a single dashboard. And we have a dashboard above that that covers like our treasury systems, our internet banking, and it's a single dashboard where we can see our entire environment health. You can drill in through those environments. This is all live with SCOM, so it's fully interactive. So you can drill through these things into health explorers and performance views. Here you can see we've got multiple websites running on there. We've got our session management. We've got the dependencies between the app pools and the websites in there, which isn't really that easy to see now. I've redacted everything from our risk team. Being a bank, we don't tend to like to share our internal infrastructure. So just to wrap up, what we've really tried to cover here today is the process to go through within our project to achieve a full IT service monitoring. So go out there, understand the architecture, design your monitoring solution with your service and health models, build your management packs with the tools we described, and then we've covered the PowerShell and working with the ops manager and the benefits that we see. So again, hopefully you've seen that with a little bit of learning and initial effort, you can quickly repeat this and scale it. So it's probably a few weeks of learning, but once you've learned it, so our internet banking took us about 6 months to achieve from start of the project to the end. We then are now looking at other services within our bank, and we can generally churn those out within a week or 2 of effort. And that's similar complexity. So the learning curve is quite big and time consuming, but once you've got over that, it's really quickly to scale it out. Cool.
Great, so we've got some related content we'll just get through here now. There's been obviously some previous sessions in the week that you could be interested in, is like automating IT operations with System Center 2012 Orchestrator. The chap, I think it was Albert, did some work with SCOM in that space. And also there was a dev track integrating dev and ops. There's that word again with TFS 2012 and SCOM 2012. There's some exam information there, and also where you can download this demo content. So when you download the slide deck, there's the URL, get amongst it. And there's David and myself's contact details and Twitter address, what have you. So if you have any questions next week when you're thinking about this stuff, pop them on through and we'll see what we can do with respects to helping out.
Also really keen, if you get into this space, to start sharing knowledge on it. So really keen to help and get contact and sort of accelerate that learning for yourselves. Some of it was quite painful, and there's a few traps you can fall into, so it'd be good if we can sort of help you through that. So we've got some infrastructure engineers who set up our environment as well, so if there's questions, we obviously didn't cover that here, but if you've got questions on that, they'll be here to answer questions afterwards. And yeah, thanks a lot for your time. Please fill out the evaluation. Apologies for running over slightly. But if you want, you can come up and ask questions up the front, or we'll be at the hub for the rest of the day. Or in the pub, one or the other. Yeah.
Just ran over time a wee bit.